So I'm very flattered to have been nominated as Star of Building Science and even honoured to have been elected a Star. So I hope the presentation is worthy of that election. So it's a pleasure to be here, and it's a pleasure in my time at Bath as director of the BRE Centre for Innovative Construction Materials to be involved in a number of research projects looking at a variety of different technologies and materials. But today I've chosen to talk about the work that I've been doing, and some of you may have seen me speak about this in the past, but to update you, the work we've been doing with straw bale. So work we've been doing with primarily with Craig White and others. So hence the title, because often it comes forward that you talk about straw bale and the three little pigs come. But hopefully, if there convince any skeptics in the room that hopefully there is some science in straw bale and there is a credible construction material and technology. This is a local authority in Lincolnshire that have procured this house here. This is a semi-detached, two homes together in load-bearing straw bale construction, and when finished and rendered, this is a different one, looks not unlike a standard build masonry house, so a thermally efficient building. Some other examples from the UK primarily. This is a college in Taunton in Somerset, a load-bearing house, building, lecture theatres. This is a more famous Wigglesworth house here in London using straw. And then in Belgium here, using it as purely as an insulation material, as with the Wigglesworth house, where you've got a clear structure. And the advantage of this approach is you can build undercover. This is a home in Helsinki in Finland, and from the outside, pretty much looks like all the other timber-framed houses in that area. This is reputed to be the largest straw bale building, certainly in UK, which is an auction room near Stansted Airport in Essex, where you can see the straw bale walls. So it's not just small homes, it's developing into educational buildings and other commercial buildings. So one approach that we've been taking is to consider that this isn't a material, but it's a product. And if you can sell it as a product to the construction industry, then they're more receptive to then selling it with straw. So there's very little difference between these wrapped up straw bales here in the field and these, obviously they're circular, and these standard bales here in this panel. But seeing it as a product rather than a material. So to conclude, development of prefabricated panels was undertaken to address practical concerns of straw bale, and we've now seen about 40 building projects using this, and straw balers around the world in other countries are also using the prefabricated approach. The development has provided opportunity to address wider barriers as well, so certification and warranty. We seek to have certification sometime next year. But the wall panels are also providing opportunities for addressing health concerns related to energy efficient buildings as well.
I thought any self-respecting scholar goes to Wiki to first understand what building science is, and I thought I'd give the first lecture. So this is what Wiki calls us: the collection of scientific knowledge that focuses on the analysis and control of the physical phenomena affecting buildings. That sounds incredibly dull, and no, it's not surprising that we have to set up these kind of events to get an audience to appreciate what we do. But if you really look at more into the details, there's of course it's a wide field of different professions that deal with building science. Really, we just heard about it. New building materials are being developed, phase change materials, vacuum insulation panels. We have psychologists working on indoor air quality, acoustics, thermal and visual quality in buildings, HVAC designers, structural design, post-occupancy evaluation to test if our buildings work, and from our end, climate responsive design, so people trying to build and shape a building so that it works with climate. So the goal of our new tool is to develop an urban modeling platform that doesn't only look at energy, but mobility, comfort, daylighting, cost, and embodied energy all at the same time. So our first attempt to show that you can actually do that, combining big data with building performance simulation, was to build a solar map for Cambridge, Massachusetts. That's a picture of the MIT campus. We then used LiDAR data, which is point cloud data for the whole city, combined it with GIS data, and we basically built a radiance three-dimensional model of the whole city with 17,000 buildings. And then we calculated for every surface in the city, for every hour of the year, the solar radiation falling on the surface and the temperature of the roofs. And now we have this highly interactive map. If you go to Cambridge Solar Map, you can basically look at each individual building and you get the solar potential plus a full financial analysis of what PV would do to this building. What we want to is really that the individual building owner designs their own PV system here, and then they basically get feedback times, yearly revenue, and how many trees they save, things like this. So this works pretty well. We've had very high engagement, and we are launching today actually a solar map for Washington, D.C. with 200,000 homes. I think building science and simulation are at a point where we can really now have an impact, not just the individual building and the AEC community, but we can arch larger societal questions. I think the question of how to teach this becomes more and more important. I think generally building science is taught in a very semi-naive way at a lot of schools where they're just used very simple concepts that don't necessarily work. So I think the whole standard of teaching has to become more mature. But ultimately, I think what is really important that we start to look at the performance of buildings, not just in a BREEAM or LEED context, but really what's the absolute energy use of a building. Right now, that's a big deal in the US. Your energy use is private, even though it's public, how much your building costs. But the moment, of course, when we have large data sets available, how much various buildings need, then it becomes a lot easier to compare buildings. And I don't want to trivialize that there are a lot of questions there linked to building occupant use of a building, but that, I think, is the ultimate measure that we want to follow.
And what I'd like to do is to sort of have a broader dialogue about how building science can actually be a fountain of creativity for the design professions. So for all the architects and engineers and public policy and building owners and manufacturers in this room, I think there's a huge opportunity here for us to use building science and to collaborate with universities and researchers to make a whole new approaches. So I've clustered the issues together, and then I'm going to illustrate what our research team is working on relative to the economics and biophilia, which is one area of building science. Eric Fromm used biophilia early on to describe the psychological orientation of being attracted to all that is alive and vital. And then the biophilia hypothesis was written up by E.O. Wilson at Harvard and Stephen Keller at Yale as the links that human beings subconsciously seek with the rest of life. I've tried to find and tease out some of the elements of the biophilic experience that I think as a designer we would need to embrace in our design and retrofits. We need to embrace views. I'm going to go through a few of these. Daylight, solar heat, natural ventilation, direct access, physical access to the outdoors, which in an environment that is getting increasingly concerned about terrorism, we actually are separating people from the outdoors. This is a really bad idea, that we need to do risk assessment to decide what is a greater risk to the health of our kids. Is it separating themselves from outdoor space, or is it protecting them from a potential terrorist attack? And then we have a whole host of biophilic attributes that I don't think there's much research on. We do not know if the sounds of nature have a critical impact on human health or performance. We don't know if the smells of nature. There is some research in aromatherapy that the Japanese have done for years on retail sales and scents and aromas, and they found very strong correlations with your desire to purchase. But the question is, does it have other impacts on our health and performance? And how important it is for us to not only see, but physically move through large community spaces. This from One Bryant Park, a new building in downtown New York City that overlooks, of course, Bryant Park, which has been made into a fantastic public space through commitment. And the question is, how important, how valuable is it for me as a worker in One Bryant Park, a high-tech office building, to look at a physical space like that, much less come out at lunch and be part of that space? Or this space, a Christmas market, which I know that there's at least a half a dozen here. And these are about the importance of physical connection to other humans. So I think the research is probably there to make this case, how important it is for seniors to be part of multi-generational, how important it is for all of us to be part of multi-ethnic communities. And with that, of course, we get a celebration of time and place and culture, and there's just such a richness. So that's the fastest I can do on triple bottom line related to biophilia. It's just one illustration of building science as a creative wellspring.